Welcome to a lesson with Dr. Powell. Now, since we have functions that are exponential functions, like 2 to the x, is there a way to undo what this function does? Like if we're trying to solve an equation or something that has something in an exponent, is there any way of getting into that exponent via an operation? Well, there is. It's called a logarithm. So in particular, log base 2. So what log base 2 would do, it's kind of like a square root symbol or whatever, but there is a word here, but just treat it like that. It's just a symbol, it's just an operator. So if I have something like 2 cubed, then what this does is this guy says to the 2 function, the 2 to the x function, nuh-uh, I don't like what you did. I'm going to put you back to where you started, 3. That's all it means. It just means what is the exponent that makes this guy if the base is 2. So for instance, if we have log base 2 of 4, we'd say, okay, what's the exponent that makes 4 if the base is 2? Well, the exponent would be 2, since 4 is 2 squared. Or if we had log base 3 of 27, we say, okay, what's the exponent that makes 27? That comes from a base of 3. Well, 3 cubed is 27, so that would just be 3. Log base 3 of 81, 3 to what power is equal to 81 is really what the question is. What exponent makes 81 off of a base of 3? Well, 4 is that exponent. So we get this nice deal going on of kind of an undoing operator of exponents. Okay. Okay, so now let's look at this in action. If we have something like this. What is log base 5 of 1 over 5? Okay, what's the exponent that comes off of 5 to get you 1/5? So 5 to what power is 1/5, right? Well, to the -1. That means this is just -1. It's an exponent extractor. Imagine just rewriting this right here as 5 to some power, and that power is what you're after. It extracts the exponent. So if we had something like log base 5 of 1 over 25, let's think about how we would do that. Let's first just rewrite this as 5 to some power, but start just simply, just go to the innermost part right here, 25. Let's rewrite that as 5 squared. Now you see this reciprocal, this deal where we have 1 over something. So let's just rewrite that as 5 to the -2. So then what do we have? Then we know, since we've rewritten this as 5 to some power, that's what this is equal to. Log base 5 of this is just -2. Okay, let's look at another one. What about log base 10 of, let's do the square root of 1,000. Actually, let's do, square root of 1,000. Let's take a look at that. What would this be? Well, let's look at the innermost part. That's 10 cubed. So we're writing everything in terms of base 10. See the square root? Let's think of it as to the 1/2 power. Then here the exponents multiply, so we get 10 to the 3/2. That means this is simply equal to 3/2. We've just extracted the exponent. Now, oftentimes since log base 10 is so common, we just omit the 10 if we're thinking about log base 10. So we just write log. And it's called the common log. So suppose we have log of and let's do the square root of 10 divided by and let's do this one right here. 100,000. How did I do this? Well, the base is 10, even though we don't see it. That's because that's because it's there when we don't see it. So we have 10 to something is going to be equal to this. Well, let's just start at each part. 100,000, that's 10 to what power? That's 10 to the 5th power. Okay, what about square root of 10? That's 10 to the 1/2. Now we think we have the same base and we have different exponents. We subtract 10 to the 1/2 minus 5. So, and now that would just simply be -9/2. So equal to 10 to the -9/2 if we work that out, because we can think about minus 5 as being minus 10 over 2. So 1/2 minus 10 over 2 is just 1 minus 10 over 2, which would be -9/2. So that means that this logarithm right here is equal to -9 over 2. So thinking about logarithms this way kind of helps us intuitively think of what they do. Thanks for watching.